So this pre-class video, we're going to work on percentiles. So I've kind of got like a quick little data set here. I've got 10 different numbers representing 10 different individuals. Maybe this was like a classroom or just a group of people. And then I kind of arrange them from smallest to largest so that 58 is in the first position, 67 is in the fifth position, so on and so forth. Okay. So if this is the only data we have, we can still come up with values that represent different percentiles. So an equation that we have to find what position, say, the 50th percentile is in. Right? So, if we kind of think about this, we've got 5 observations here, 5 observations over here. There's a value such that would exactly split this data in two, giving us a 50th percentile. But the equation that we're going to use to find the position, right, of where the percentile we're interested in is located at is going to look something like this. Where n represents the number of observations in our data set, and p represents whatever percentile we're interested in. So we're going to say that we're interested in, for this example, what would be the value that would be the cutoff for the 90th percentile? Kind of the 90th percentile reflecting that that value would be greater than 90% of the other observations and less than 10% of the highest observations. So forget if I remember, I think I said this, but these are going to be kind of representing height in inches. So we're looking for the 90th percentile of height based off of this data that we have, okay? So we're going to plug in our percentile we're interested in, and we also have what? Our sample size is 10. So 10 plus 1 times 90 over 100. We're going to get 9.9 is the position that 90th percentile would be in. Now, obviously we have an issue. We have the 9th position, we have the 10th position. There's not a 9.9th position, right? But what this equation is going to tell us is if we did have more observations, this would be the location that it's in. And so we can use this and use the values that are in the 9th and 10th position to kind of what we call interpolate between the values of 75 and 80, which are in the 9th and 10th position. So this equation identifies what positions are we in between. Well, 9.9 is in between the 9th and the 10th position. So the 90th percentile will be somewhere in between the values in that 9th and 10th position. But we can't simply take an average. It's not simply that 77.5 is going to be the height that's the 90th percentile, because this equation tells us, well, 9.9, we're much closer to the 10th position than the 9th. So the way we're going to do interpolation, we're going to look at this decimal point, and we're going to use this to create essentially two weights, kind of like the weighted mean. So 0.9 is going to be one of our weights, and the other weight would be whatever gets us to 100%, or in a proportion standpoint, to what it gets us to 1, so 0.9 and 0.1. So you'll use whatever's to the right of that decimal from your position equation. That'll be your first weight. Your second weight would be whatever would get you up to 1, right? So that those two weights add up to 1, representing the proportion of 1, right, or 100%. So then we're going to look at the two values and say, okay, which one are we closer to? So 9.9 is closer to the 10th position. So we're going to weight the value in the 10th position using that higher weight, right? Since we're closer to 80, right, or that 10th position, it's going to be weighted by 0.9. Then we're going to add to that whatever value is in the position that we're further from, this case, the 9th position. That value is 75. We'll multiply that by 0.1. Maybe a different way of probably could have written this to keep it, since we have the weights out front every single time, would look something like this, right? But this is essentially our interpolation. This is going to factor in that the value of the 90th percentile is closer to the value in the 10th position, right? So we go ahead, we plug this in, I believe we get 79.5, which kind of makes sense. We were really close to that 10th position being this 90th percentile cutoff. And so our 90th percentile is going to be a value that's really close to whatever value is in that 10th position. So this is just kind of the first quick look at how we do percentiles. We'll talk more about these in class on Wednesday.